Hey guys, we're in Khan Academy and we are working on graphing linear relationships word problems. This is actually one of my favorite skills they have in Khan Academy. I love it because it takes real life context and it forces you to view it in a graph. So not just creating a model like a table or a model like an equation, but now we're modeling it with a graph and we can visually see with our eyes kind of what's going on in the context. That's my favorite part of this. I will let you know ahead of time on all of these problems that you're going to be doing here in this section of Khan Academy. You're always going to be wanting to look for a point you can plot. All right, that's the first thing you need, some point to plot. And then the second thing is you're going to want to find the slope and build off of the first point to plot another point. All right, those are the two things that we're going to be looking to do here. Let me just leave that up on the screen and then we will I'll talk about that with every single problem. I'll probably come back to that situation. So we have Rip Van Winkle fell asleep for a very long time. When he fell asleep, his beard was, let me underline this or highlight it. His beard was 8 millimeters long when he fell asleep. I'll include that too. When he fell asleep, his beard was 8 millimeters long. And each passing week, it grew 2 additional milliliters or millimeters. Milliliters would be volume. It grew an additional 2 millimeters, all right, every passing week. Graph the relationship between the length of Rip Van Winkle's beard in millimeters and time in weeks. All right, so the very first thing you gotta do is figure out over here on plot a point, all right? Is there a point we can plot? Well, every week that goes by, he's growing 2 more millimeters. So after 1 week, 2 more millimeters. After 2 weeks, 2 more millimeters. After the 3rd week, 2 more millimeters. It's a recurring value. And whenever we see that, that means it's the slope. It's something that's happening over and over and over and over and over and over and over again. That's the slope. The other information is going to be a little bit more helpful for plotting a point. When he fell asleep, his beard was 8 millimeters long. What's important for us to note is when it says weeks here, what's the beginning of the weeks? Like what's time equals 0 of the weeks? And when we say 22 weeks, we're saying 22 weeks from when? In order for time on a graph to really make sense, you kind of have to define what is the beginning of time. Time is tricky because in real life, there is no beginning of time. Time has no beginning, has no end. It's infinite. But there are certain things that have a beginning and an end. In this case, we're talking about him sleeping. All right. So when he fell asleep, when you start to sleep, that's the beginning of sleeping. If you say you slept for 8 hours, well, how would you know to calculate that? Well, you have to have a beginning and an end point of when you fell asleep. So we're saying when he fell asleep, that's your time is 0. When he fell asleep, his beard was 8 millimeters long. So on this one, we know that when time is 0, his beard was 8 millimeters long. We, in this case, know the y-intercept. That's the point we can plot. The next part to this is we need to find the slope, which we already referred to, and build off of the first point to plot another point. So each passing week, his beard grew 2 additional millimeters. So what I like to do for all these problems is just create a real quick XY table. At 0 weeks, it's at 8. After 1 week, it grew 2 more millimeters. 8 plus 2 is 10. After 2 weeks, it's 2 more millimeters, 12. After 3 weeks, 14, so on. And look for a point that I can plot. It looks like on Khan Academy, they're restricting me to, I can do 1, 10. It won't let me do 10 because 10's between 12 and 8, but it won't let me go there. So if I go to 12, I got to go over to 2, all right? So I used information to plot a point. Then I figured out what's the slope, what's the rate of change, which was given in the story problem. And then I built off of my first point to plot a second point using the slope. In this case, the slope, I used it to find this point over here, 2, 12. And that should be the correct answer to this problem. All right, we got that one right. What I'm going to do is I want to keep this thing over here. So I'm going to just do undo the entire way. And then we'll go on to the next question here. All right, next question we go. Sean tried to drink a slushie as fast as he could. He drank 5 milliliters of slushie each second and finished all the slushie after 50 seconds. Let me highlight some things. He drank 5 milliliters of slushie each second. Okay, that's one piece of important information. And finished all the slushie after 50 seconds. Finished all the slushie after 50 seconds. Graph the relationship between the amount of slushie left in the cup in milliliters and time in seconds. We need to first figure out, how can I plot a point given this information? Well, he drank 5 milliliters of slushie each second. So he's drinking 5 milliliters, 5 more milliliters, 5 more milliliters, 5 more milliliters. That's a recurring value. It's repeating. 5 plus 5 plus 5 plus 5 plus 5. That's slope, rate of change, slope. So that's the slope. He finished all of the slushie after 50 seconds. That's going to be the thing that gives us a point in this context. In this context, the slushie is gone, which would be 0, right? There is no slushie after 50 seconds. So that tells me that I can plot a point at no slushie left, right? Like on my y-axis, my slushie is 0, right? There's no milliliters left. And on my x-axis, it's at time equals 50 seconds. Again, in this case, time is 0 would mean that when he first starts drinking, ready, set, go. That's time is 0. And from that point forward, we start, timing how long will it take Sean to drink this thing. Now we're going to need to work backwards from that point to plot another one, right? Find the slope, which we'll work on in a second here. Build off the first point to plot another point. All right, so we're going to build off of this point down here and work backwards to find another point. He drank 5 milliliters of slushie each second. That's the slope. Every second, 5 milliliters. If I create a quick little XY table, at 50 seconds, there's no slushie left. If I were to work backwards in time, 1 second prior to that, there was 5 milliliters of slushie. 1 second prior to that, there was 10. 1 second prior to that, there was 15. 1 second prior to that, there was 20, and so on. Because every second he's drinking 5 milliliters. So working backwards, every second prior, there was 5 milliliters more of slushie, right? If I try to graph these, it won't let me go past the 45. Like I can't get to 46 or 47 or 48. So it looks like I need 45 on my table here. 45 would be 25. And it looks like I could plot that point. Now you may be asking, is it possible for me to plot a different point? Like what if I plotted this one or that one? Or what if I did some calculation and I found out the y-intercept? That's fine. You just need to plot one point and then plot another point. And as long as those points lie on the correct line, you're going to be correct. Like I'll leave my green thing over there and it should work. Perfect. But notice that it would have worked also had we did the point that we wanted because it's on the line. So as long as you're plotting 2 points that are on the line, you're going to get this correct. All right, we got 2 more questions to go here. And like I said, I really enjoy these problems because it takes real life context and it gives a lot more purpose to why we're doing what we're doing with graphs. I know we're not solving super serious problems in the world right now. We're talking about Sean drinking a Slurpee, but it's giving you an idea of how math can be used to represent life and represent context. Wilbur landed his plane, causing it to descend at a rate of 0.2 kilometers per minute. He reached the ground after 15 minutes. Graph the relationship between the plane's elevation relative to the ground in kilometers and time in minutes. Okay, so let's take a look at this. Let me highlight some things. This thing's in the way. All right, Wilbur landed his plane, causing it to descend at a rate of 0.2 kilometers per minute. He reached the ground after 15 minutes. Well, a couple things that you may want to think about is the word descend. If you don't know what the word descend is, I would go to Google and type in descend, see what that means. It means move or fall downward, all right? Descend means the plane's starting to land, all right? We have descend, and then we would use the word ascends. It ascends at a rate of whatever. So descends is the word for land, all right? Landing, going down for an airplane. So it's beginning to land, it's starting to go down at a rate of 0.2 kilometers per minute. Again, that's our slope, 0.2 kilometers every minute, 0.2, 0.2 more, 0.2 more, 0.2 more, or 2/10 more, 2/10 more, whatever you want to call that. He does reach the ground after 15 minutes. So at 15 minutes, which is between 14 and 16, right in the middle, he is on the ground, which means that he actually is down here. He's on the x-axis because the elevation of the ground is 0 in this context. It says the plane's elevation relative to the ground. So when it's on the ground, it would be 0. All right. So the elevation is 0. And since the elevation is 0, then this goes right on the x-axis at 15 minutes. Now we need to figure out the slope, which we know the slope is 2/10 or 0.2 kilometers. I think what's easiest in this context is to say, okay, 0.2. Slope is actually one of the fewer things in life where fractions are better than decimals. Decimals are great for money and great for a lot of things in our society. But slope is actually better to be a fraction. 2/10 is what that reads, right? 0.2 is 2/10. That's the equivalence of 2 over 10. And if you didn't know this, like let's say you had a problem similar and you wanted to figure out how to do that, you could go here and say convert decimal to fraction. I bet you'll find something handy for you. Oh, there you go. The first one, calculator soup, 0.2 or 2/10, what do you want to call that? Calculate. It's actually 1/5 because 2/10 can be reduced, right? It can be simplified. So I'm actually going to simplify that down to 1/5. Calculator soup did better than I could there, right? They already simplified it for us. So it's 1/5. Let me go ahead and go back to this. So we have a slope of 1/5, which what that means is that our change in y over our change in x is the airplane is going, it's actually going to be negative because it's landing, right? It's descending at a rate. It's going down 1 kilometer every 5 minutes. It's going down 1 kilometer every 5 minutes. To give us an XY table, we already know that when our X value is 0, our Y value is, sorry, add that backwards. When our X value is 15, right? When it's been 15 minutes, our Y value is 0. 1 minute before that, or actually we can't do 1 minute because look at our slope. We're saying it goes down 1 kilometer per 5 minutes. So let's not do 1 minute. Let's go back 5 minutes. 5 minutes prior, using the slope idea, right? 5 minutes prior, if I go backwards 5 to 10, we know that this rate of change, this triangle here, the slope triangle, it's going down 1 as it's running 5. That line's not plotted yet. That's why my triangle doesn't make sense. It's going down 1 as it's running 5. So if I go backwards 5 minutes in time, then I can go up 1 kilometer. So it would be 1 kilometer. And this should make sense because my change in y is 1, and my change in x is, in this case, -5, which gives me a -1/5 slope. I can now plot that point, which is 10, 1. And again, you could have done some other work to calculate maybe the y-intercept up here or something else. But at 10, 1, there you go, 10, 1, that would be a proper point. Or you could have found 5, 2, or you could have found 0, 3. Any of those would have worked. I am going to do one more. So let me real quickly kind of clear off. I'm going to clear off even the instructions I had there. We're going to start from a fresh screen here. Oops. Show summary. I did good. Let me go back to my assignments I assigned. Let's just do one more because I like to do as many problems as I force my students to do. Suraj took a slice of pizza from the freezer and put it in the oven. The oven heated the pizza at a rate of 7.5 degrees Celsius per minute. Let me turn on my little highlighter here. The oven heated the pizza at a rate of 7.5 degrees Celsius per minute. And it reached the desired temperature of 80 degrees Celsius after 12 minutes. So we need to find a point to plot. The 7.5 degrees Celsius per minute, that's a repeating value, right? The pizza is heating up 7.5 degrees every minute, 7.5 degrees, 7.5 more degrees, 7.5 more degrees. That's the slope, rate of change. It reached the desired temperature of 80 degrees Celsius after 12 minutes. So at 12 minutes, it's at 80 degrees Celsius, which is going to be all the way up at the top. This point we know is true because at 12 minutes into heating up the pizza, the temperature was at its desired point, which was 80 degrees. We're going to work backwards and we're going to work off of that point and we're going to work backwards to try and figure out another point to plot. Let's try a XY table, which is my go-to plan for helping with graphing. We know that at 12 minutes, it's at a temperature of 80. So let's work backwards. At 11 minutes, the rate of change here, it's heating up at a rate of 7.5 degrees Celsius. It's heating up. So we know that this line is going to be going upwards in some way, shape, or form, right? So that means that working backwards, we're going to have to go down, right? So 80 minus 7.5, that's 72.5. 10, working backwards, minus 7.5, that's 65. I may be able to plot 10 and 65. Let's see if that's plottable. 10, 65, which is between 70 and 60. That should work. Bingo. All right. So that's how you do these problems. Find a point to plot, figure out the slope, and then work off of that point to find another point somewhere else in the graph. All right. Keep fighting, guys. Keep getting better every day, one day at a time. Keep fighting.